Yeah, hello and a very warm welcome to the European Digital Week. It's a great pleasure and honor to be here today, and I'm looking forward to some interesting talks and interactions. And before I start with our little talk, I would like to thank the organizers for putting together this interesting conference on manufacturing and automation and robotics. And from our side, we would contribute today on some facts and interesting insights on IoT data platforms and how they can impact the manufacturing process. And for that, we have put together a couple of slides for today. Basically, we start with a little background to set the context, so that the context also for the talk today. Then we would like to talk a little bit about the recent developments on IoT and IoT platforms and how significant it is, not only for the industry, but also generally speaking. Then, as we said, as the main topic is, what is the actual impact on the manufacturing process? Where and all do we need them? What can they do? And how useful are they? And how will they change the way we manufacture things? And with all this theory, we would like to give you then some small use cases, things which we have done, which give you then a better understanding on what's how it is really used. And after that, we will summarize and sum up a little bit what we just discussed and introduced today to you. And yeah, that's pretty much it. And with that, let me start to give you a little bit of context and background on what we are talking here about. So basically, the Internet of Things is the network of physical machines, industrial assets, and consumer products that are able to share data and communicate over the internet. As you see under these three headlines, you can summarize really every equipment. Obviously, from a use case perspective in the manufacturing process, it's basically your machine park, but it's also when you are in a machine industry, the machines you sell, and that could be also for industrial products as well as consumer products. So even your or especially in consumer products. We've seen a lot of development in the last couple of years, and they have also direct impact on the industry, on the manufacturing process. So if you just take, for example, all the smart home appliances like your smart fridge, your smart washing machine, while and for that matter, consumer products are the IoT part of it is sold easier because you can sell it to the consumer as an added benefit that the fridge gives you a signal when to stock it up again. But with that being said, the moment it's internet enabled, it gives also a feedback to the manufacturer, and from the pure usage of the fridge, of the washing machine, you can get valuable insights, and that could impact your maintenance cycle of these machines. That could also impact the design of the next generation of these machines, because for the first time you actually see and know what the machine is doing, how it's used, and you don't assume on how consumers are using it. So, and obviously this kind of data is best used, or in order to make use of this data, you need the right data infrastructure ready. And one part of your data infrastructure is your IoT platform. The platform basically which collects all the data from your IoT devices, but in an ideal way also connects it to other data sources. And obviously, the more data sources you connect, the more insights you can ultimately generate, and the more correlations you can discover, and the smarter you will become, and the more or the better you will be enabled to anticipate certain things. As I said, with the example for consumer goods, because I'm mentioning it just because we all have fridges and we all have washing machines at home, so that's an easy point to resonate with. But as I said, it's not only for us. They're doing this. The manufacturers they're doing it for themselves as well, because when you compare it with the profile of your clients, when you compare it with the city you're selling it, when you compare it with many other factors, this gives you the valuable insight, as I said, to design the next generation products and also to make sure that you maintain it at the right level at the right time. So talking about IoT and the IoT sector, I think it's not a big surprise that IoT is not a new development, and IoT is definitely not only a thing which is here to stay, but it's also a thing which is here to grow, and which is literally growing exceptional and exponentially, as you can see here in the graph here, and will have a much bigger share in all for all devices going forward, so that shows you that the market as such has also grown in a big business, and not only in the business, it also generates a lot of new data points, and the big data volume is growing so fast that the challenge is not only to apply that and to deploy IoT solutions. The challenge is really to not miss the point, to not miss the valuable insights, to not miss the new discovery of what's happening with your product, with your market, also with your competitor to a certain extent, and stay ahead of that and react faster, because if you don't do it, as I said, your competitor might do it. So that's why it's a growing application. It's a growing sector in the industry, and that's why you need to stay ahead of it, and that's why it becomes more and more important that your infrastructure to handle the data is well laid out, well in advance, or goes along with the development. So, which brings us to the definition and architecture of IoT platforms. With the chart we showed you with the growth trajectory which we anticipate over the next even only 4 or 5 years, and with what we have said already, IoT platforms have to evolve, because they have to deal with a much bigger volume, with a much bigger variety and velocity of data that IoT solutions will bring to the table, and that's why it's no surprise that the building blocks on how Internet of Things or IoT platforms have been designed have been changed dramatically over the last couple of years. So in 2016, you had 8 major building blocks which are highlighted here. But when we come to 2021, we have already 24 major IoT platform subcomponents, which are mainly grouped along for basic headlines, which is one is your application management and enablement. That's providing the ability to rapidly develop, test, and seamlessly manage IoT applications. Then you have the data management enablement. That's providing the ability to ingest, store, and analyze data from your IoT devices. The telco management, that's providing telecommunication companies the ability to manage the connectivity of your IoT devices at scale, because unless you use edge computing, if internet is involved, there has to be a communication one way or the other. Even if you put a small little sensor in your machine or in your product, or even in a thing like a tire, the tire has to communicate. So there has to be the telco infrastructure of the ready that the data can be communicated to wherever it is then analyzed. And of course, the device management, providing the ability to remotely configure, monitor, and manage IoT devices. That's another a super important aspect in this whole IoT platform business, because again, if you have, the bigger the organization is, the more remote it is. It also depends. I mean, again, if you look at the machine tool business, if you sell a machine and you want to collect the data, then that's a critical component, a critical part of your data management and handling. Again, this is a little bit, while this is not, before we talked about the volume of IoT devices, here we talk about money, and money is always interesting, because that's, as a private enterprise, that's why we are all here for. At the end, we have to see how we can try to make some form of money. So the interesting part is simply that by 2025, 50% of all industrial enterprises will use industrial Internet of Things platforms to improve their factory production, and that's an up from 10% where we are right now. That's dramatic, and 60% of this market is within your factory environment. And while we are here in the European Digital Week, and that's something which that would be an interesting factor to have an open discussion about, is if you look at the figures right now, Europe and the US are the leaders, but in the next 5 years they will be easily surpassed by Asia, and that's something which has various reasons. One is the growth factor, one is also the more liberal aspect on how to deal with data, and we will come to that in a certain aspect later on, and maybe we'll also come, I guess we will also hear about this in the whole course of this conference, but that's something from a European perspective. If Asia becomes the biggest region for IoT platforms, we in Europe have to be careful to monitor this and make sure that we are not falling behind the bandwagon. On the other side, if we have solutions for that, it's a good market for us to expand our business. Let me talk now a little bit about the impact on the manufacturing process, and here I have put the main highlights on where we can see where we will have direct impact from faster decision making, predictive maintenance, certain cost savings, real-time asset monitoring, etc., which are quite on the one side quite obvious, but what I would really stress here is the last point on the right side, is that up to 60% of the value created will require the ability to integrate and analyze data from various IoT systems, and I would go even so far, from various data points. I mean, a lot of IoT solutions, if they are super technical, super specialized, they remain a very closed circuit, a very closed ecosystem environment, where you can get super insights and super valuable insights on a sensor environment, on a special problem that you want to solve. But the power, or it will be even more powerful once you take this data and integrate it with either other IoT devices, whether you include with other data sources, but that makes it even more attractive. If you take your ERP system, you take environment, demographics, etc., that all are valuable data points, or it's all available data which you have. And the moment you integrate it all, you overlay all this data in a metadata system, you can generate new insights, new correlations, which can be super valuable, because you can discover things which we all haven't anticipated right now, and that's why it's very difficult to give examples, because that's something new, and that's why it's so important, and that's why you have to have a close eye on these developments. And then at the end of the day, what you want to achieve with all your digital transformation is to reach a new form of lean manufacturing, of lean management. And the interesting thing is, when you look at the graph here, is that the digital transformation is the center point. What all companies will go down the path. Some faster, some slower, and it has three major components to impact certain aspects, which is systems, technology, people, and you have then the certain aspects where you would like to see the improvement. But everything can be achieved faster or easier or smoother is when it's underlying a proper data structure, proper data infrastructure, for which an IoT platform can be part of it. And when I mention here people also, I think that's a key issue in all this digital Industry 4.0 IoT developments. The important management task for all of us is that we pick up people on and show them the advantage of it, and not make sure that these developments, anyway they will come, but these developments are something for the greater good, even for them, and even because their work will be different. I wouldn't say necessarily easier, but it will be different and hopefully more exciting. And that's the thing, that's the message which we need to, especially from a management point of view, which have to come around to pick up people at the early stage. Now, as I said, I would like to have some quick highlights on some use cases or some practical approaches. One is the TI data platform, which we have developed within our system in our company, along with some companies. And the importance, what I would like to make here, apart from the whole technical infrastructure, showing that this is a super flexible setup. It's using open source technologies mainly, which makes sure that it is relatively cost competitive, and it has a high cybersecurity aspect in it. I think the most important thing, what I would like to stress right now, because we don't have all the time to go in all the details, is the input data sources from client systems. I mean, if you look at a pure IoT platform, that will really focus on the last sector here, on the sensors and your IoT information. But with a good platform, and I just take here ours as an example, but all the other IoT platforms should give you the same benefit. The benefit is really that you can expand and you can connect all the other various data points in your company and try to make sense of it all, as and how you want to grow your company and how you want to serve your clients better. Because let's make no mistake, any effort you do here has to either make your company more efficient, generate new revenue, or make you faster in the market to serve your clients better. If none of the 3 points are touched, then there's no point in going down this path anyway. And with this, I'll give you a small example on some fleet management work we have done for a construction equipment manufacturer. That was for a European application. It's a global company, but this is a European solution. And as a matter of fact, we have done a lot of fleet solutions recently. That's still in high demand. That was basically to operate, to make sure the current fleet of the machines sold in a specific market, and to track up to 400 parameters. And with that, again, to make sure that you can serve your clients faster and better. And what we did is we looked at a bidirectional data transfer, localization and geofencing via GPS, and we integrated into the ERP as much as possible, and other technical features. Again, I would like to stress this integration in the ERP, because again, you have an external data source, an additional data source, and you combine it. That all enables us to have the machine data to be ready at any given time, to plan machine commitments, when can be a machine available, where and when, what are the maintenance schedules and needs, and what machines are available, and hence the commitments to clients and to location of place can be improved significantly, and with that also the revenue is able to be improved. And with that, I would like to conclude. with a couple of points which I think are important key takeaways, which I think also some of my other colleagues here in the conference might touch upon. I think it is no surprise, and it's a given that we will have a huge increase in connected devices, and the connected devices will be anywhere and everywhere. I just mentioned it earlier that companies are already talking about sophisticated RFID chips, which create some form of data which you can use in tires, which you can use even in castings, which withstand a couple of 100 degrees. So connecting devices and connecting things is really the name of the game. And with any more connected devices, more data will be created. That means also the functionality of IoT platforms, which has already evolved, will evolve even further, need to evolve very further. And that's why you need a very complex, not very complex, but a very flexible system. And that's why the TI data platform, which I quickly introduced today, is not only built on open source technologies, but it's also super flexible. And we always, while it's not an off-the-shelf product, it's a highly flexible product, which is more like you can see it like a toolkit, and that's, I think, important, especially if you're a small and medium-sized manufacturing company, that when you go down this path of an IoT platform, that it's very flexible, so that you have the ability to play around and to make sure that it is really up to your needs. And with that, I would like I have summed up for anybody who goes down this path or want to expand a couple of points which everybody should look out for when going down this path, when integrating an IoT platform in their software development, in their IT plan. One is obviously the track record in the IoT business. So I mean, a lot of it's always easier if these platforms are already deployed in the IoT field, and whether they can show, especially when it comes to IT platform, a key criteria is sometimes the volume of data. Is it really able to digest and to operate with huge amount of data in a speedy way? Because only then you can have real-time information. The ecosystem of alliances and channel partners is the next one, which is super important when choosing the right partner for going down the path of an IoT system, because obviously the big guys, they have already come up with ready-made solutions, be it your AWS, your Google, you name it. And while these are important components, sometimes they need, in order to make this fully workable for you as a client, they need to have an adjustment for your needs, and that's why on the one side, the IoT platform partner needs to have a good grip on these technologies. At the one side, he needs to be also capable to fine-tune it for your need. Obviously, it has to be, especially in the manufacturing space, user-friendly and effective. So that is why I say, especially in the manufacturing industry, that's an industry, especially when you try to use it across the whole value chain of the manufacturing process. If you want to use it on the floor, you need to always, you don't want to have go through a big training exercise to bring people close to certain IT applications. Then it has to be open and interoperable and developer friendly. That's the point which I have been stressing again and again in this presentation, is that only focusing on your IoT data, what you get from your IoT devices, is nice, but it's not good enough. So you should always make sure that you use other data sources as well to make sure that you have a holistic 360-degree view of what's happening, and use this data even more impactful than if you limit yourself on the IoT part alone. And with that, it has to be scalable and secure. I mean, as I said, I guess there will be some more talks on cybersecurity. Scalability, obviously, I mean, that's a given. You will start maybe in one place or in one application, and when you go down the path, more developments will come, more IoT devices will come. So you don't want to go to the drawing board again and start from scratch. So that is very important. And the other thing is, most of these, unless you use a lot of edge computing, which is again not a standalone solution, but some form an important solution in IoT solutions. And I would assume that somebody will talk about edge solutions as well in this conference today. Everything sooner or later will end up in the cloud, and that's why cybersecurity is making sure that the IoT platform uses certain security parameters is very essential. And also, when you budget for it, a certain budget needs to be always set aside for cybersecurity. At the same time, all the cloud applications, I mean, there are only 3 major cloud providers left, unless you make your own cloud. But these are widely used not only in the industry but in the whole world. As I always keep saying, if you use internet banking, then you use the cloud. And if you trust your money to the cloud, then you should also trust, provided you have certain security features engaged, you should also not be scared of the cloud when using it in your manufacturing process. And with that, I guess I would like to close today. As I said, I hope, or I'm looking forward to some of the other talks here in this conference, which will be complementing what we talked about. It. You might have noticed that with no word, I mentioned the buzzword of AI and machine learning in this whole talk, not because I don't like that, but I think, again, because there are others who talk about it. And that being said, I'm a strong believer that no AI or no classical machine learning models will work until your infrastructure is right. And that's why it's so important that you spend a good amount of time and maybe also some money on having the right IoT platform ready when you also want to embark on certain AI solutions. And with that, I thank you for your time and looking forward to staying in touch with everybody.
Based on the predictions of the International Data Group, by 2022, 93% of all data will be unstructured data, and 80% of the unstructured data is text. Hence, we understand the importance of building strong NLP models, namely natural language processing models. These models are not new to the scientific community, but today we can outperform traditional NLP techniques by quite a margin. This started a new revolution in the AI domain, and the first AI for text analysis tools are already created. Today, decision making in business is based on data. The challenge there is to find good quality data to make the best decisions. Until recently, we could process massively only structured data, that is, numbers. But what about all the hidden gems in the unstructured data? Imagine that you have a hotel and you want to know more about your guest experience. How could you ever achieve that efficiently without considering their emails, their reviews, and voice under consideration? How can you understand if they feel positive or negative about your business? On top of that, wouldn't you like to know which aspects of your business are doing well and on which ones you should improve? I remember a hotel manager who could see low ratings of her hotel on TripAdvisor, but she could not comprehend the issue of those low ratings. She could read some of the 1,000 reviews online and still have no idea about the overall picture of the hotel, as she could not transform the unstructured data, the customer reviews, into structured ones and measure it. If she could manage to achieve that, she would efficiently monitor the hotel's performance on different aspects such as the food service or the food quality, the hotel's location, the room's cleanliness, etc. Imagine if she had a model on which she could feed all of the written reviews and receive as an outcome the total number of positive and negative reviews per aspect. This would help her gain a high-level view of her business and identify the particularly nasty elements. An AI model that deals with text could help her prioritize the hotel's needs and act more efficiently as a hotel manager. Assume now that you already have a few thousands of unstructured data. For example, you have product reviews or consumer complaints or emails or any other text from which you would like to extract insights. Now, this is a very challenging and time-consuming process if you execute it manually. The power of these models, of the NLP models, is that they are tireless, they are fast, they are accurate, and easy to use or even update when you want to. Their only weakness is that they cannot guess how would you like them to label your data. So I highly suggest you to have a clear idea of what you would like to achieve and how you should teach your model before even getting started with developing an NLP model. I have worked with small and big data, with models which are robust against noise and with models which are robust against big volumes of data. I have focused my efforts on high parameters tuning and algorithms benchmarking to discover the best solution for a specific task. I have also dived deep into creating datasets and test cases to understand how a model behaves in a particular spectrum, how to improve a model's performance, and discover corner cases where the model doesn't perform well. From my experience so far, I saw that there are mainly two types of engineers. The ones who try to improve performance by focusing on improving and automating only the code, and the ones who focus more on the data and try first to understand the model based on its input-output pairs, and then modify it. Let's see one crucial reason why the first tactic, focusing on the code, is not very efficient. Imagine that you have a polymorphic tool with a bunch of settings according to the different usages. Now, if you make the settings before you even know the specific task that you want to do, then how can you know the proper settings? As these models are very complicated, this is impossible. Imagine only that an NLP model can consist of millions of parameters. It is not easy to optimize the performance without falling into the generalization overfitting trap. The cherry on top of these problems is that you have to explain the model's behavior to a technical or even to a non-technical audience, the customers. Models explainability is one of the biggest problems when it comes to AI models, as it is hard for consumers and stakeholders to trust a model that they do not even understand. It is hard for engineers to automate a model's correspondence to different cases if they do not know the full spectrum of these cases. Lastly, it is hard for data scientists to discover corner cases when these are rare and they are not even existing in the training data. but they might exist into the wild, into data that the model has never seen before. Regarding the customers, the best approach, in my opinion, is to work with them on specific business cases and involve them in their projects, so they will be able to understand more about the different topics, and by exposing them to different minor tasks like data labeling, they can understand better how these models are working. Additionally, you can write short business cases with easy to understand examples in order to give clients a high-level view of what an NLP model can do, how much time they can save using a model like that, and finally, how it can help them add value to their business. Lastly, creating blogs and small user stories, you can educate the customers and inspire the technical managers. These tasks require people with specialized knowledge and storytelling skills. But these tasks are essential for the growth of a business that works with AI models. Today, Python already has many libraries for different tasks, which are needed to build an NLP model. This is why Python is heavily used in machine learning today. Neural networks are huge models which demand prominent computational force for their training. This is why the system's design here is very important. To reduce the training time from days to hours, we use parallel and multi-GPUs computing. Also, different settings like stopping criteria should be modified such as we take the best results in the minimum time. Time is money here, as the training from scratch of a language model on a specific task can cost more than €30,000. So you have to design perfectly a system which does not break easily and it is scalable. You also have not many chances to try things out, as every trial is super expensive. Finding this combination of technical skills is complex. We have lack of talent in this area. And since technology is a fast-changing field, there is a lot of pressure and responsibility that falls on the engineer's shoulders. Luckily, some leading domain companies like Google have trained and free-sourced NLP pre-trained cutting-edge models like BERT, and someone can use them to reach faster and cheaper to a downstream trained on a particular task NLP model. So, actually, Google offers a pre-trained neural network that understands a language, and we can use it as a base to downstream train it on a specific task on a particular domain. In other words, I could take a model like BERT, which already understands English, and train it on customer reviews coming from a site like booking.com and teach it how to separate positive from negative comments. This is a downstream task called sentiment analysis. But there are many other tasks that an NLP model can conduct, like question answering, which is a job that we see in chatbots. So let's repeat that. A pre-trained on a specific language model like BERT can be found for free online on pages like Hugging Face. Now we can retrieve this free model like a library, and then we can further train it, or in other words, fine-tune it on a small dataset specific for the NLP task that we want to execute, like the question answering or the sentiment analysis task. Now let's see more details and tips for the data scientists who handle data which is used to train these models downstream. What should we be aware of? Which are the challenges in this training? When we want to train these NLP models, the first wall that we hit is to find suitable training datasets. Let's say that we want to train a sentiment analysis model that understands if a text contains positive or negative feedback for a business. Now, we will teach the model to read the comments based on their context by showing all the examples that we have in our training data to an algorithm. To collect these examples, we need annotators, or in other words, people who manually label comments. It is essential to involve business in this process because data labeling gives us a better understanding of the model and our data quality. It is also crucial to help companies to annotate data or label data properly in order to achieve high quality training datasets. After creating our training set, it is time to train the model and check out its performance. How we do that? We test it by providing examples which the model have never seen before, and we see if our model has learned from the training dataset. Now, if the output makes sense, meaning that a positive text is labeled from the model as positive feedback and respectively a negative comment is labeled by the model as negative comment, negative feedback, negative text, then our model has learned how to read the text properly. If not, if the output does not make sense in all or in some cases, then of course we need to investigate further these cases, change our training set accordingly and retrain the model. Different issues may result in having a wrong output. All these cases are based on the training dataset. Maybe our model misses information, so we need to add examples that provide this information in the training data. Perhaps we have provided some examples with the wrong label, so we need to remove these examples and retrain. Maybe we have not split our text correctly and it contains positive and negative feedback, so it is not clear for the model which labels to assign. Maybe we are biased about the label and our model is actually correct. For example, we see a 5-star review on booking.com and we expect that it will contain positive feedback. But in the comment, it's actually written a negative comment, like the only thing that I do not like in your hotel is that it is far away from the beach. But it has a 5-star review. Hence you understand why data scientists have to dig deep into the data in order to understand an AI model's behavior and discover necessary changes to steer its behavior in another direction. Another big problem with NLP models and their training data is that languages are very vast fields. They might hide many different meanings. There might be many synonyms in order to describe something. Some people use sarcasm in their comments. And someone can explain something very differently based on their education, work, language skills, and so on. Hence we understand that creating an excellent training dataset which will describe the actual data quite well is super challenging, is almost impossible. The real data is an inhomogeneous dataset with a wide variety and meanings that are changing based on the domain that they are used to. For example, in the domain of customer service, the word cheap could be used with a very negative meaning as the waiter is cheap, When he realized that I will not give him a tip, he became rude. And in some other domains, the word cheap can have a very positive meaning. Like, for example, in the food industry, we could have a comment like that: this restaurant is cheap, which is actually a positive thing. Knowing that text is difficult even for people to comprehend, but at the same time precious information is hidden in it, we do expectations management first in this area, and then we have a look at the big advantages of the NLP models to remember which are our alternatives and why we bother at the first place to solve all these big problems that are generated during their training. I will leave you with this. In data science, we make decisions based on our data. Data collection is not a big issue today. On the contrary, the volume and the velocity of big data force us today to use powerful AI models to process information faster and better by using brutal computational force and intelligent algorithms to achieve data transformation and knowledge extraction. Having this task automated by cutting-edge software is very impressive. It saves us a lot of time that we can actually use to understand these tools and then use them to process information massively. Information leads to knowledge, and we can use it to respond better and quicker to changes, understand our business, and make better business decisions. This is how technology and artificial intelligence can help us avoid overwhelming and at the same time learn from all this data and focus on how to take quicker, smarter decisions regarding big, complex problems. Thank you very much for watching.
Hey everyone, you are aware that the face of the global industry is one that is constantly changing. So 2021 was no exception to this rule, and we had some interesting manufacturing advancements taking place this year in 2021. However, we should differentiate that while in 2020 the global headlines were mostly dominated by topics such as the pandemic, closed sectors, reduced consumption, and shrinking production, in 2021, this year, we had headlines focusing more on the accelerated implementation of robots in manufacturing, of the global chip shortage, some interesting initiatives in the field of battery production, for example, and other industrial niches, and of course, the rapid progress and growth of industrial automation. Now, which were the key technology advancements in manufacturing this year? I'm going to focus on three small trends which I saw evolving this year and which I believe we should observe, keep an eye on, and they can evolve further in the coming years. Now, the first trend, which is emerging and I believe can be very interesting and implements a manufacturing innovation, are the microfactories. Um, Now, this year, according to the International Federation of Robotics, we had global robot density reach a new record high. Robots have a key role to play with any type of manufacturing innovation, basically, but especially with microfactories. Now, what is the concept of a microfactory? Um, is, for example, the assembly line, which has been here for decades, the most efficient way to assemble, for example, an electric vehicle. Well, this year, some startups started saying no. Another way, which is more efficient, is a microfactory. Um, so, what is a microfactory? Well, basically, creating highly automated microfactories where, for example, electric vehicles can be assembled by multitasking robots, who actually break the approach, which was pioneered from Henry Ford and used for most of the automakers globally for nearly a century. So nowadays, micro plants would produce tens of thousands of vehicles per year, and that's far fewer actually from what traditional auto plants produce. But traditional auto plants require far more workers and typically produce, of course, more. But the assembly line approach is very capital intensive, and you have to have high production in order to make any margin. While microfactories actually can eliminate some of the most expensive parts from uh, from the production in a given auto plant. Basically, the microfactories focus on assembling by multitasking robots, combined, of course, with humans, and not so much on expensive capital intensive operations. Um, it's still early on to discuss whether building microfactories actually is economically feasible and whether it can shape the face of the global auto industry. But I believe that the trend definitely has potential, and making more niche and more not so mass production via robots definitely can be economically viable. And I believe this is a trend all of us professionals in the fields of manufacturing, robotics, and et cetera, is one that is actually useful to keep an eye on. The second trend, which I have noticed this year and I believe will be interesting for the coming years, are the micro fulfillment centers. Now, can, for example, a small e-commerce company compete with a behemoth such as Amazon? Well, actually, companies developing micro fulfillment centers say yes. The micro fulfillment concept is one that is based around providing space to multiple tenants and deploying robots to run it, but it can also potentially involve companies taking space within larger warehouses that they don't own themselves. So a typical micro fulfillment center would involve robots and humans. It's scanning and controlling stations, basically running the whole micro fulfillment center. And the robotic solution, of course, is key, and it makes the micro fulfillment center differentiate. An integrated set of both hardware and software that can be implemented in the customer's own warehouses and automate the process of selecting, moving around, packing items, can be very efficient and as same as the microfactories, which significantly reduce first the investment and second the costs for running it. The micro fulfillment centers reduce the cost of fulfillment operations, sometimes by a margin of 75%. And both the microfactories and the micro fulfillment center don't remove humans from the chain altogether. They are just a solution which is less capital intensive and and more cost reducing. So I believe that those two trends combined together can really shape, especially the future of manufacturing startups and both large scale producers willing to experiment and conduct their operations in different matters. The third trend, which I'm going to discuss, is one which is specifically occurring this year, and it revolves around how companies and especially manufacturers resolve supply chain issues. Now, as all of you know, most businesses have faced some type of supply chain issue nowadays in 2021. But the key issue is actually how do we cope with these? Now, for example, companies which had deficit shipments of chips and other electric components have been using a couple of exotic approaches, but ones that do work and ones that do represent type of manufacturing innovation. For example, part of the companies do re-engineer their machines. so that they need fewer chips or components which are currently in deficit. And this also includes rewriting software and firmware to support alternative types of chips. So it's a really large scale project. We saw also that some of the companies utilize other means, for example, implementing technology for liquid cooling of microchips, which allows the higher performance of devices even with fewer chips. And we've seen that producers which are more dependent, for example, on raw materials, do obtain cheaper and faster raw materials, for example, with the likes of aluminium by recycling household appliances as well as recycling multiple other raw materials. We know that recycling was not the most popular option when the global supply chains were running smoothly, but nowadays it's becoming something which is of interest to more and more companies. Now, we also saw that a lot of manufacturers do implement supply chain software and solutions that learn from multiple data points, which analyze deadlines, delivery, their quality, and they filter any type of traders and providers who delay delivery, who deliver poor quality products, as well as any um, illicit opportunities. And we've seen that such type of software solutions, they basically allow manufacturers to build a completely new supply chain. And a lot of the companies have utilized such options to basically introduce a completely new supply chain for Europe or for the US with local suppliers. And basically, this type of newly set up supply chain can keep their operations running. So these were three of the manufacturing innovations which I observed this year. I'm aware that manufacturing is a constantly evolving one and that the innovations are occurring not only every month but on a daily basis. I believe that it's important to observe whether small scale production and fulfillment operations, as well as supply chain changes, how they can influence manufacturing. And I believe that will these trends deepen and evolve, or will they be just a temporary solution? We are yet to observe and find out. But one thing is certain: observing those trends is key for us to understand how we can move faster, better, and run our operations in the most smooth and profitable way. Thank you for your attention.
Hi everybody, my name is Eros Marcello, and welcome to my session, Human Interfacing AI for Mental Health Maintenance During Prolonged Microgravity Exposure. I'm really stoked for this talk, as well as the rest of the speakers and sessions here at American Digital Week's International Conference on Robotics, Automation, and Artificial Intelligence Systems. I hope everyone's just as excited and thrilled as I am. COVID, just to set up expectations here, COVID has had me take a little bit of a break from the presentation circuit, and though these are pre-recorded, still getting back to, I mean, I like speaking, but the whole speaking along with slides for some reason is, I have to get used to it again. The whole presentation format, because I'm more of one or the other sort of fella. But nonetheless, let's dive right in. Just to give a quick overview and agenda here, as we have a finite amount of time, and I want to be respectful of everybody's time and participation. We're going to be taking a deep dive into not only this particular application, which is how human interfacing AI, human augmentative artificial intelligence, and machine learning can have tremendous impact, has the potential for tremendous impact in an extreme edge case like spaceflight, but the larger concept is how using edge cases and conceptualizing, researching, designing, developing, and deploying for those edge cases can ultimately enable you to glean insights and approaches, techniques, and then some for other relative applications. And I think that's a really exciting. These are all really exciting verticals that have a lot of adjacencies, and I'm looking forward to shedding light on this. And I've been looking forward to this talk for a while. So let's get to it. Just a quick introduction of myself. My name is Eros Marcello, again, and I design and develop human interfacing and human augmentative AI, including voice assistants, chatbots, even though I hate that word. I prefer textual agents or cognitive agents, and multimodal human-computer interaction, which this talk is essentially going to, the end, what I'm proposing here is an aggregation of the aforementioned. Furthermore, what really ignited a very visceral love affair and passion for aerospace and the new space race and space travel and exploration altogether was my participation in the SpaceX Hyperloop competitions that really cemented it. Of course, I've had a lifelong fascination and affinity for anything having to do with space or emerging technology for that matter. But this was a really, really amazing. I'm adding this in because it's a really important to understand where the space element comes into play, and it was really got my ideas flowing on how, because at this time I worked at Samsung, so I was working on Bigsby, so I began already hypothesizing where those two would interest, where the two facets, my two vested interests could intersect. So this is at the time of we conceived this is the team or those of us who had a hand in manifesting what I'm about to show you all. So these are two friends of mine and colleagues. Corinne Patel is former research scholar at NASA and a lead on our Hyperloop team, R-Loop. We were the only non-student team to be invited to compete at SpaceX. That's how we met. And Sean Schemmel at the time was involved with scheduling. He's a friend of mine. He is the voice of Goku, for those who don't know, from the Dragon Ball and Dragon Ball Z Super GT franchise. So this is more of what I'm about to avail to everyone is more of a theoretical, half thought experiment, half case study on what we were going to propose. And this was before COVID, but COVID certainly validated our perceptions for this. Just going through a little bit of introduction. There we go. So due to our limited time, you can peruse through the slides. I'm sure they'll be made available to attendees. So this is just my approach. We're going to breeze through this, but this was the approach that I and my cohorts utilized and adhered to throughout this process. We will just pass this here. So this is what this quote right here ignited this entire concept. A digital assistant that recognized emotions and responded to astronauts with empathy might vastly improve space missions that take months or years. That was the MIT Technology Review. This is a very real area of research, and as you'll see in the next slide, a pretty tremendous concern when it comes to the viability of longer-term spaceflight, which is definitely in our crosshairs when it comes to returning to the moon, as well as the potential colonization of other planets, such as Mars. To even get there poses a lot of challenges. Spaceflight in general is a dubious endeavor, with a lot of obviously a lot of danger. That goes without saying, but this is the crux of the problem. Billions of dollars worth of investment, innovation, and infrastructure will ultimately be rendered moot if human beings are unable to psychologically withstand prolonged tenures in space. There's NASA in particular, and as well as their constituents, have amassed quite a bit of research in this area since humans, entered microgravity and entertained spaceflight. So it's a very fascinating subject. I implore you to, for those interested, to deep dive into just this without the conversational AI or multimodal human-computer interaction or ambient computing elements. This alone is just a fascinating subject, and one that someone can foster expertise in exclusively, if one were, inclined to. And these are the obstacles. So obviously this is traditional, user research, understanding the end user and their needs. That's with any AI enriched or navigated product or service. Obviously the end user has to be kept constantly in the line of sight. So these are the factors, and situational design plays an immense role in this entire process, and in this particular use case especially. So severe depression, extreme isolation, irrational anxiety, paranoia, insomnia, psychoses, these are all documented and studied occurrences that happen upon crew and passengers in space flight, and will pose, especially the psychosis element. And that tooth icon is a nod to a famous case where a astronaut in the ISS had a dream about a toothache. Fast forward just a relatively short amount of time, he became paranoid and began trying to, I believe, tear his tooth out, if I recall correctly. And they had to actually restrain him for a considerable amount of time, I believe. And that just goes to show you what can occur in a high-stress, isolative scenario, such as, and this is in low Earth orbit, obviously, at the ISS. It's only, I imagine, going to be amplified when you think about the time of traveling to a planet such as Mars. And this is the end user, again, situational design, but more so this is and that's the last slide focused on the intrinsic elements. Think of these as the extrinsic. So constant danger, physical degradation. This is, again, a really fascinating subject because these are the idiosyncrasies that were considered in designing and developing the solution, because everything from your bone density to your blood flow alters in microgravity, and the effects of that, are definitely have a high degree of variability from person to person, but undoubtedly contribute to one's mental state, as anyone's physical health does. But again, you have a lot of different moving parts in this edge case of spaceflight. So it's really fascinating and this could be a problem in and of itself, to use deep learning to find commonalities in between, the certain mental states or dispositions that occur, and their correlation to one's physical health in space. Homesickness, that goes without saying. And then cabin fever, obviously confined spaces. You're with the select group of people for a prolonged amount of time. And again, we've seen this in the ISS, but again, think about all of the, aforementioned variables and factors in conjunction with, potentially even longer, an even longer time horizon. So again, the potentials for, NASA has done tests in the desert and simulated, isolation for longer missions or even on other planets, but we've, really yet to see, obviously haven't seen what's really going to occur in the field as of yet. We can only go off of earthbound, things that can embody certain like folks that work in remote areas and research in Antarctica. I mean, just some examples off the top of my head here. And these are the solutions. I mean, obviously, with any product ever, you have to assess what's out, and this isn't necessarily a market, but these are this is what I guess one would call competition or other efforts. So, as you can see, one's a rover with Henry the Helper, developed by Akin AI. I believe they're an Australian-based company. And then you have Simon from IBM and Airbus, which very much looks like it's from IBM and Airbus. And this poses, any type of approach or effort is certainly admirable, as again, this is a very important use case, but I mean, I don't think for even maintenance, and certainly not in a state of duress, do I see these necessarily being options that would procure any sort of actionable solution. I'm sure they've been developed upon, but that's what's out there at the moment. So our solution is to make something from hardware to software, top to bottom, made specifically for space travel. So first and foremost, obviously, you have to have a chassis that is relatively mobile, small, and can either follow or monitor the user in the environment that it's in. So you have to also consider rad hard or rad tolerant components. Particularly radiation hardened components have specific programming languages that need to be used for drivers and compatibility. All of this plays into. I won't get into the nooks, the nuances of all of that, because that could fill a few hours, but a consideration to make, and all of these ultimately affect the design, implementation, and everything in between. So this would also boast sentiment and tone analysis. Voice as a biomarker and voice biometrics is a very real field, and something that even there was a really cool, I forget what the company, but their approach during COVID was, or their assertion was, that they felt that with speech recognition, they could assess if someone potentially was inflicted with COVID due to permutations in their speech patterns, or their raspiness in their voice, or wheeze maybe it would catch. I'm not sure if it focused on paralinguistic components, but this would certainly be a study in that. As well as to a relative element too is the calibratable personification, and this is borrowed from one of the few things where sci-fi can inspire real-world AI problem solving. Here is what does personality really mean in the terms of a cognitive agent or AI agent, pardon me, and that is a true NLP problem and a linguistics problem, as in if you have tunable parameters for personality, as in Interstellar, and this is where this is borrowed from with TARS, which is their robotic AI that its hardware was configured. I mean, it's a really good science fiction representation of a true robotics and artificial intelligence solution, and I found the idea of being able to modulate the personality to within a fixed degree really fascinating as far as what that means, because obviously you're not just dealing with diction and vernacular, you're dealing with again a lot of paralinguistic and nonverbal elements such as cadences, tonality, context. So again, a very fascinating and a very complex problem. But the whole point of this is that not only does it approach a solution not only does it approach a realistic and it's aiming to solve a real problem, but ultimately it's a robust approach that aims to at least get its beak wet in creating the solution, and by incorporating a lot of different variables as far as what what does 50% humor equate to from a speech synthesis engine, or a multimodal solution like colors via a GUI in conjunction with speech synthesis dialogue. I mean, the list goes on. So from an interfacing to augmentative, and I'm a avid believer and supporter of the notion that anything in emerging technology really needs to boast a utilitarian function. It needs to benefit the user and ultimately provide them a skill or ability that they didn't have before. That's true innovation. So with this, the purpose also it plays on behavioral psychology, because if you establish the utilitarian element, and you'll see this in the demo that's forthcoming at the end of the presentation. If you establish trust by being able to execute tasks for an end user. That's going to just be out of the box. The end user will be more apt. It will solicit habitual use from them more, and with that comes trust establishment, which is very important for any type of cognitive computing or artificial intelligence software. You definitely want the trust from the end user, as you would with any application or program. So we have a thing called agnostic cognition, which can be toggled on and off, and that essentially enables and bypasses the mental health assessment and monitoring mental status but it's all ultimately part of the same picture. I mean, I know this is a little bit scattered. It's a pretty tall order and a really, really vast concept. It's just a lot to try to explain, but you'll see in the demo the minimum viable product, and it's just a high-level overview. And this is our on-off premise approach. There's a human-in-the-loop system. Obviously, that's paramount, especially for any AI initiative in its infancy. Some scaling, as far as or how the plan is to scale in functionality. Any type of AI development is an incremental. It's definitely a marathon rather than a sprint. Ironically, even though agile tends to be applied. That's good for I guess okay for development development practices, but as far as the overarching product life cycle, it's definitely an incremental one, and it's not necessarily ever really finished, because the technology ferments, and then all of the facets beneath it do as well, and there's new approaches and findings from assessing success metrics. So again, these are just boilerplate. Oh my God, COVID has done a number on me. Boilerplate development process. SWOT analysis. The conversational paradigm as far as the utilitarian via the humanistic, and what both really manifest themselves as in products, and where success lies and what's viable and what isn't. Space edge and edge case. So this is really important, and this is the big picture, and it goes to show the long-term goals of using space as an edge case, and that's from advancing the medium that we're utilizing. So as I mentioned earlier, NLP. I mean, these are new experimental approaches that can be deployed for this new exciting use case. You can democratize the research. You'll get especially with something like this, a plethora of findings and observations that can be propagated across many institutions and bodies. New mental health tools, which is one of the most important elements of it as well. So you take what you learn from the edge case and then you use it to refashion earthbound tools in this case, and also for people where they're have earthbound roles that are that share commonalities with the dangers of something like space flight. So miners, oil workers, field researchers, and then this is, again, a lot of this was conceived before COVID, but COVID has certainly validated this entire application through and through. And we did call it Blue Moon AI. All of this then has a loop back to its original application, which is space travel. And as the space race grows and establishes itself and becomes more real, as it has, especially in the past few months, the sky's really the limit. And these are the happy byproducts of this, the hopeful happy byproducts. So increases access to help with new mental health maintenance and monitoring tools. Remote patient monitoring also is super important. It's becoming it's a growing element to a lot of health products and healthcare products in general. And then this is, again, in furthering the space of multimodal human-computer interaction, which is the seed, along with conversational AI and touchscreens and traditional graphic user interfaces. All of these are modalities. Siloed, none of the above siloed offers the advantages of them deployed and utilized in conjunction with one another. So in the way that, the mouse and keyboard certainly didn't absolutely make the paper and pen go extinct. Touchscreens didn't. We're still using mice and touch bars. And then voice is the latest thing being hailed as the whenever you hear folks like voice is that's what it's going to be like. Everyone's going to be searching for Google with their voice. I mean, yes and no. But again, voice and speech recognition is just, again, a modality. This is all going to culminate into what we hope is a lean and seamless distributed intelligence ecosystem with a lot of players and a lot of people pushing innovation and its initiatives and thought experiments and proposals such as this that, at the very least, get the brain juices flowing in that direction. And that's ultimately what this entire talk is about. Is this going to manifest itself? Is it possible to do some of these things? Unlike, many companies that make a lot of promises with their tech, who knows? Conversational AI and NLP human interfacing AI certainly isn't a language problem. It's largely a paralinguistic one, meaning that you have a lot for a AI to interface with a human. There's going to be and have that interaction feel natural. There's a lot of moving parts and a lot of elements that go into a conversation. It's not just dialogue. It's not just speech recognition. So things like this help explore that. And this is just contact information. I thank you guys for your time. I appreciate anyone who sat through this. I know it was a little scattered. I'm getting back into the swing. I've done a lot of public speaking, and I've tried to keep this as casual as possible, keep it as interesting and entertaining as I could. And reach out, LinkedIn, website, email, and I'm always up to something cool. And I appreciate your time and hope you enjoy the rest of the conference and speakers. Talk to you guys soon.
Hi everyone, my name is Daniel Ebrol. I'm going to be discussing some of the topics involving robotics, automation, and using artificial intelligence systems. In particular, today I'll be discussing using AI surveillance for public safety and security. So my particular background is currently I'm a global business development director at IREX AI. My background includes working for some of the national security centers in the United States while obtaining a master's degree in business with an emphasis in security management. I've managed some of the largest sporting venues across the world and managed some of the largest events as well, including an event with 5 former presidents in attendance. So now I operate in the smart city, security, safe city space, and how I'm seeing the market evolve with what my education has brought as well, in terms of combining that, my experience, and the way that artificial intelligence is becoming a major part of security operations in cities, governments, and large corporations worldwide. So I'm going to share my screen in a second. What we're going to touch on today is, first of all, where the technology is today, how the technology can be deployed, what are the drawbacks with the technology, and where I see the future involving artificial intelligence and cities around the world. So I'll just share my screen real quick. There we go. So here you should be able to see up now that with today's topic, which I'm going to be discussing, is using artificial intelligence surveillance for public safety. My background, like I previously mentioned, is I have an MBA with an emphasis in security management. I obtained that at the University of Southern Mississippi while working for the National Center for Spectator Sports Safety and Security. In that role, it allowed me to kind of gather a lot of intel on where the market was going with security management, because at the National Center, we were certified to view and basically give our rubber stamp on any upcoming security solutions. So I've been overseeing it really since around about 2015. So first of all, cities right now currently aren't ready for this transition to artificial intelligence. First of all, some of the things which I'll discuss in this presentation today is the ethical concerns. Because once we mention artificial intelligence systems such as facial recognition, license plate recognition, and so forth, there is lack of trusted governance, there is a lack of transparency. There is also things like the Netflix documentary, which discusses coded bias. And there is obviously the media and this sort of fear of an Orwellian type future using artificial intelligence surveillance. So this is something that I wanted obviously to discuss today. The other things which are drawing cities back as well is that there is lots of lack of collaboration. They may think that artificial intelligence is too expensive. There's a lot of disjointed departments in cities from the public and private sector. So right now, I think the biggest thing with the drawback with artificial intelligence, especially in the Western countries such as the United States, is this lack of ethical standards. These ethical AI standards and the lack of them is something which needs to be addressed and is being addressed. There is various entities now across the United States, one of them being the newly created Technology Integrity Council. So look out for them. They're going to be a pretty big player in this over the next few years. So the ecosystem really for safe cities, how does the technology work? How can you use artificial intelligence in surveillance cameras? So first and foremost, cities around the world already have existing infrastructures, meaning that they already have surveillance cameras, they already have IoT devices. So how can they utilize those to enhance the public safety and security? First of all, you need to be able to connect to those cameras. So there is software companies out there where cities can give their a stream of the camera to the private cloud of an organization, and they can run artificial intelligence modules. I will talk about some of the artificial intelligence modules which are already out of the box, kind of worldwide, and I'll also discuss my thoughts on where the future is going with artificial intelligence modules as well. Also, there's this big data. If you imagine right now, the technology is available. So if you can connect to surveillance cameras in cities, you can perform things like Google-like search surveillance. So you can upload a photo of an individual and it will come up in chronological order if and when that person's ever appeared under surveillance. And same for vehicles as well. So this is enormous technology. This is revolutionary technology. So the ability to go back in time and do that search surveillance is going to save so many lives, but also there is 80% of eyewitness accounts are incorrect. Now, with the ability to just perform that search surveillance, you'll be able to find people instantly or when they will last appeared under surveillance. On the flip side of this, which I'll discuss on the next slide, is the use for instant alerts. And there is a moral obligation to have these instant alerts for things like missing children, missing people, and potentially wanted terrorists as well. So, and the last part is that collaboration, because we see a lot, the future is going to be collaborative security from the different department entities to also possibly the public and private organizations being more intertwined and being able to share that data. I think that there has been a massive disjoint over the last few decades in terms of that information sharing. Now the technology is here to receive these instant alerts, but also share them with other entities. Again, there is a moral obligation to do this because of all the good that can be brought through this collaborative security. The ability to be able to receive things on instant message now from devices and browsers, basically anywhere, and creating these virtual war rooms. I think what we'll see in the future growing and growing. It's already active right now across the world, but I think we're going to be seeing more and more of it across the United States. So once a artificial intelligence software is connected to a surveillance camera, what can be run? So first and foremost, it depends on the quality of the camera, it depends on the lighting, it depends on the angle, and it depends on the objectives of what the city wants to achieve from that. So hypothetically, there are 20 plus artificial intelligence modules that can be run effectively in the market right now when connecting to surveillance cameras. This is going to evolve and evolve and evolve. For now, I like to put them in 3 different categories for what you can do once you connect to a surveillance camera. Exhibit A is threat detection, B, people analytics, and C, vehicle analytics. I like to split them up into these 3 categories. First and foremost, once you connect to the surveillance camera, you can do threat detection. This means you can receive instant alerts if there is a weapon detected by an individual under surveillance. If people are falling, dangerous crowd densities, intrusion detection, fire detection, unattended items, glass breaking, and people on railway tracks. So these modules, for example, let's just touch on weapon detection. If an individual appears under surveillance with a weapon, depending on the location of that camera, depending which city that's in, it can trigger an alert to either a specific individual or a specific department. So if you imagine an individual can receive something on their IoT device with a live stream if a person ever appears under surveillance with a weapon. So that is extremely powerful technology in terms of response time. this is going to be revolutionary in terms of giving accurate information earlier than we've ever anticipated before through the use of artificial intelligence. Again, intrusion detection, that's going to be absolutely key to critical infrastructures, water plants, oil and gas, so forth. The list goes on. Again, as we've seen, dangerous crowd densities, this can be applicable in stadiums worldwide. I originally come from Hillsborough in the United Kingdom, and Hillsborough was the scene of the largest sporting disaster in the UK, and that was through dangerous crowding, and unfortunately 96 people lost their lives that day. This is going to be something which it's obviously the world that we live in right now with the pandemics and so forth. There is different thresholds that you can set for things like crowd density. Again, imagine all these alerts, and they're going to be sent to specific departments and specific personnel. Moving on to everybody's favorite topic when it comes to artificial intelligence is facial recognition and the use for the ethical use of facial recognition as well. So there was a quote recently by the United Kingdom, the Home Office Biometrics and Surveillance Commissioner, as calling out there is a moral obligation from the public sector to now harness and use this technology. So ethical facial recognition, this is something which is going to be needed a lot of work on standardizing, a lot of work on the best practices regarding it. But I think that one thing that not many people would argue with is if we only use facial recognition to trigger alerts, if missing children or missing people or known wanted terrorists ever appear under surveillance. For example, right now I work alongside many missing children organizations across the United States, and what they do to try and find missing children is absolutely crucial. But the ability for cameras which never sleep to be able to trigger an alert if this missing child or this missing person ever appears under surveillance, to trigger an alert to an entity, that is revolutionary. And that is something which cannot be ignored and shouldn't be ignored by the governments across the world right now. In addition to obviously people analytics, there can be suspect tracking. Obviously that when it comes into that search surveillance kind of type, if there is a person that is wanted, kind of on the run, so forth, you can upload a photo of that individual. It's going to come up in chronological order if and when that person's appeared. Moving on to video analytics, I'm going to touch on the ethical use of facial recognition a little bit more, because I think it's obviously it's a topic which a lot of people do have an opinion on. Video analytics as well is something what smart cities will be able to do and are doing right now around the world, from connecting to surveillance cameras. These alerts to trigger alerts for traffic jams, number plate recognition, detecting traffic, parking violations and so forth. This is nothing new, but it can be now done from surveillance cameras instead of specialized license plate recognition cameras and so forth. So all these modules can be hypothetically run on the existing cameras which are already located in cities and organizations around the world. So this is kind of the blueprint, and it gives you a nice visualization of how these smart cities are going to be operating and are operating around the world using artificial intelligence surveillance. So if you imagine connecting to a number of sensors, obviously for this conversation, we're talking about possibly drone cameras and fixed cameras, PTZ cameras in cities. So you're taking the stream to a secure private cloud. All the stream from these devices come into this secure private cloud. They are comparing the databases which have been preloaded by the government and so forth, or the specific user. So you're taking a stream from the cameras to the private cloud. You are comparing that with the databases of individuals, of vehicles, or event triggers such as crowd density or fire intrusion, etc. So you're comparing all that existing pre-filtered who needs to receive what from the government databases, and then it shoots it to the specific users. So, for example, we're taking a stream in from a fixed camera in a city. It comes to the cloud. It compares it. If any of the database, if any of these people, bang, a person has appeared who's on one of the government databases, and it's going to trigger an alert to a specific department or a specific user. This is going to be the future of AI surveillance, and it already is right now. The technology is there. So how do you make this ethical? How can this be done correctly? How can this be done in a way that best suits the society and doesn't bring in this Orwellian type future that none of us want to see? So first and foremost, these databases and how the client uses the data, all is auditable and transparent. So that means that everything that the person does, if they perform search surveillance, if they receive an alert, this is all logged and it can be audited by a third-party vendor, such as, again, I mentioned possibly the Technology Integrity Council in the United States or various other entities around the world. So anything that they do using this powerful artificial intelligence system can be audited, it's transparent, and everything is logged. Meaning if they perform a search, it's going to be seen and you'll be able to see exactly which user has performed which search. And it's obviously, it can all be permission based as well. So this gives you a nice visual, and it gives it from one specific camera, it can trigger alerts to all different departments and connect to unlimited thousands of users and thousands of sensors. And for this conversation, obviously, we're discussing surveillance cameras as the sensor. So this, like I talked about, the moral obligation from this, the AI mission to finding missing children. AI software companies around the United States are forming partnerships with missing children organizations all over, because these organizations have the databases with the photos of the missing children. These need to be offered to the cities free of charge. They need to have a specific user that needs to receive the alert if the child ever appears under surveillance. Again, there is a moral obligation to use this AI to help combat human trafficking. The ability to receive alerts if a child ever appears under surveillance who is missing has been described as revolutionary. And it is revolutionary. It's an enormous leap in technology. And the response time is going to be absolutely huge. So I'd like to just finish this conversation on where the AI market is going, and I brought some figures to the table to discuss. First and foremost, the video analytics that we talked about. The artificial intelligence modules, once you connect to cameras, is predicted to hit a $12 billion industry in the United States alone. The smart cities realm, where kind of this fits in, it's the smart cities / safe cities vibe, and that's going to be a $2.5 trillion business. Private clouds, $126 billion, and obviously there is various others as well. So this is kind of my overview of where the market is going. I hope you've enjoyed this. I hope it's been a little bit educational, and it's with this technology now, we have to bring it to the forefront and use artificial intelligence for good. And that includes the standardizations and using it morally, using it ethically as well. Finally, I'd just like to thank American Digital Week for having me present today. And this is my LinkedIn, Daniel Ebrol, MBA. You can just find me on there if you have any questions, or you can reach out to American Digital Week. So thank you guys for having me, and I hope you've enjoyed this. And again, feel free to ask me any questions if you'd like. Thank you, guys.
Hello everyone, my name is Matthew Emmerich, and I want to help you get into the field of artificial intelligence. It's a huge field. There are a lot of ways to approach it, and we will try to cover on the majority of those. And it doesn't matter if you're starting earlier in your career, later in your career, you're about to retire. If you're interested in something, go for it. You can do it. All right, let us begin. So, where do you start? That is the first problem that you will have, I had, that everybody has. And where can you go? What career choices are there? I assume that you're not going to choose AI as a hobby, though you could. I applaud you for it. Maybe you want to go into research. Maybe you want to work for some corporation. There are so many paths. Every path is unique anyway. Your path will be different from everybody else's. Your journey is different. And I'm just here to help you with some basic advice. And the first piece is the question of whether college is the right choice for you if you either plan to go back or are just starting out. And if you do go, what majors and minors are there at the undergraduate level? Do you need to go to graduate school? And what other methods are there if you choose not to go to university? What overall skills are required, both hard technical skills and soft human skills? Which ones are the most helpful? Do you need to build a portfolio? We'll touch on this a lot later on. What projects will help you the most? How do you organize them? How do you network to find good opportunities? It helps if you know people. It gets your foot in the door. It can give you so many opportunities. Highly recommended. How do you stand out in order to get hired into the field? Because even though there aren't enough people to fill the AI roles or data science roles that exist, it's still hard to stand out. It honestly is. So I'm hoping to help you with that and to give you some basic advice. So you're starting out. You're either going to university for the first time, you're going back, you're just changing careers. It can be kind of scary. But you're going to feel the fear no matter what you do, so you may as well just do it. Just do it. You can do it. Start with research. Start with the end in mind. Where are you going to go? Where are you right now? Now, there are two major feelings when changing the field like this. Either I'm an imposter, I can't do it, or I already know everything. These are two ends of the spectrum. You're somewhere in the middle. You'll go back and forth. You're not an imposter. You can learn whatever you need to learn. Anybody can learn any skill. You're not an expert. I don't care what courses you've taken. Have you created a true AI, some AGI program? Then you're not an AI expert. You may be an expert in some technique or another. Probably not. But you're not an expert. Now, do you generalize or do you specialize? This is very difficult to go back and forth with because generals have the most fun. Specialists are the ones usually seen best for most roles. So what are some examples? Maybe you like computer vision. Specialize in computer vision then. If you like language and linguistics, focus on natural language processing. If you maybe have a biology background, genetic algorithms. You are at least starting somewhere. Focus on what you want to do, where you want to go, and if you want to specialize, specialize. If you are a generalist, your path is a little bit harder. It can be a lot more rewarding. You can jump back and forth. You can think of solutions that specialists cannot, but it's a lot more work. That's the same boat I'm in. The key for anything with AI or any field this complex is to never stop learning. It's very important. The field changes every day. You need to change with it or you'll be left behind. Know the latest techniques. Know who's who. Keep up learning new skills. Learn something every week, every month, something. And keep up your network as well. You never know what the future will bring, as we've seen in the past year and a half. So, starting with the end in mind. One of the biggest things you hear about in AI is a data engineer or a machine learning engineer or a more general AI engineer. These are the plumbers. These are the electricians. These are the ones who do the infrastructure for an AI project. For instance, a data engineer will build the pipelines that the data scientist will later use. The machine learning engineer will build the machine learning pipelines. So it's all about data pipelines. Honestly, it's the same for all three. They are just different titles reflecting the exact same role. Maybe you want to specialize. Maybe you want to be more than just the plumber. You could be a natural language processing engineer or developer. Same difference. Here's where you focus on audio input and matching words, matching intent, analyzing the emotion, summarizing data, or you are more interested in vision. So computer vision engineer or developer, you focus on graphical or video input. You do object segmentation. You do a lot of different things. It's not just machine learning, though that is a core component with both of these specialties. Maybe you want to take a step back and focus on the business side. So you might be a business intelligence developer or analyst. That's great too. There's a lot of data out there that's not just audio, it's not just linguistic, it's not just visual. It's a lot of data. There's so much data created every single day. A great entry point is to become a data analyst. This gives you a lot of experience working with data overall. You look at patterns in the data. You learn how to present your findings. It's a great stepping stone into an AI field, a more technical AI field. Maybe you want more of the hardware side of things, though. I'm sure you've heard of robots before. Most people have. And a lot of people have either an overly negative mind about them, thanks to movies like Terminator. And some people have a more positive, thanks to movies like Short Circuit or other works of fiction. But robots are a huge physical component to AI, and they always will be. And this is a great way to get into it as a robotics engineer. Maybe you want to go into the actual edge of the field. Research is your best bet. This can be at a university, it can be at a corporation. You have a lot of options here. This usually does require the PhD. It's a lot more work to get into, a lot more effort, a lot more time, higher cost, but it can pay dividends. If this is your field and you're just starting out early, this is a great way to really dig deep. You're still marketable to businesses, but you super specialize typically. So be very careful about that. There is the sexiest job of the 21st century, the data scientist. This is when you care more about the data. It's usually more the business side as well. So a data analyst may become a data scientist later on with more experience. And it's not a real AI focused field, but it is an option if that's the way that you end up wanting to go. Now, not every career that is AI related has been invented yet. One up and coming role is the AI ethicist. This is more of a philosopher type of role. You take a lot of ethics courses, you apply it to AI. It's great for the legal field. I read about a legal firm that focuses only on AI law. Good for them. There would be more of this. There would be a lot more once self-driving cars become more mainstream, if they ever get to that point anytime soon, and they start running people over or causing property damage or get their driver killed, because it's going to happen. It is going to happen whether we like it or not, and legal firms will step in whether we like it or not. So that is one option. There are technical writing options specifically for AI. So you could dive deep into the field overall and work on your writing skills also. You have a lot of options. If you really want to have an easier time figuring things out with this field, figure out what you want to do and just go for it. So, university. Should you go? Should you not go? If you do not have a bachelor's degree, you should go get your bachelor's degree. It opens more doors than anything else will. You technically can go to boot camps, but a lot of roles once you have the bachelor's degree. You better have a strong portfolio, a strong network, and you better hustle if you do not have the bachelor's degree and do not want to get one. We'll talk more about undergrad level work later on. But if you're coming from a completely different field, let's say you are an accountant, you're great at math, which is a very important skill for AI, but you are underwhelmed by accounting. You're adding up numbers all the time. You're looking for missing money. You're doing this, you're doing that, but you want something different. AI is a good field, and you will probably want to go back to your university, add on a minor, maybe in computer science. It's an option. If you're coming from the humanities and you want to work a more technical role, you can get away with not going to university. It's easier if you do go back, earn a major or minor, or multiple. You don't have to. If you want to solidify your foundation. Now, I have minors in philosophy and psychology, majors in cognitive science and computer science, and a master's in computer science. I'm already looking at going back to get my second master's degree, this time in artificial intelligence, but I would also benefit from a stronger mathematical foundation. Redoing my calculus, redoing my linear algebra, taking more stats courses, that would be a huge benefit to me personally. Maybe it is to you as well. A lot of people take the minimum amount of math, and that's not always the best bet for you. Or maybe you just want to go back. That's part of the reason why I'm looking at my second master's degree. It opens up doors, but if I could, I would be a professional student, and I would love to just keep taking courses and collecting more and more degrees. I'm kind of weird like that. Now, when doesn't university make sense? If you already have an undergraduate degree or a master's degree, it makes a lot less sense. Most people who earn a second master's are earning something like an MBA, so they can move up within their domain of interest. Like I said earlier, I'm going back because I want to. Now, if you already have a good foundation, you have a math minor and a computer science major or minor, you've taken all these courses, you are a good developer. You are doing these boot camps and building up a portfolio and networking and such. You don't need to go back. So save your time, save your money, save your effort, and focus on things that make a lot more sense for you personally. If you're coming from a related field, software engineers, you probably don't need to go back to earn another degree. You can learn a lot of things on your own, even the math if you really want to. But university probably does not make all that much sense. Now, what are the majors and the minors? The most important one is computer science. You need to be able to program, even if you're not looking at AI from a technical point of view, which you don't have to. Mathematics is great as well, more for a minor, but if you go into research, a math major can be a huge benefit. Statistics is big right now thanks to machine learning, because it's all statistical programming when you get down to it. Psychology If you want to go deeper into the field, a psychology minor where you choose which courses, such as developmental psych, neuroanatomy, cognitive neuroscience, things like that, things I've taken each and every one of those, then that can be very helpful. Philosophy I left off this list, but it's in the same category. It's more about ethics. It's more about logic, which is important. Theory of knowledge, theory of mind. All helpful courses. You can take them without doing a major or minor. Major is kind of overkill for the most part. Cognitive science. That combines computer science, psychology, and philosophy. You can take linguistics courses as well and count those, typically, depending on the university. It's a great major to pair with a computer science major. And you can still earn minors in philosophy and psychology at the same time. That's what I did. Electrical engineering, if you're going to go into robotics, that is a great option and kind of necessary as well. Data science. There are more degrees in data science offered these days than there used to be. Great option if you want to focus on the data science side of things or the business side of things. And finally, AI as a major or a minor, typically a major for now. We're seeing more and more of this. Same at the graduate level, but this usually covers everything. It usually is very technical focused. So some cognitive science on top of the AI would be a huge way to round yourself out. If you want to focus more on the technical, this is a great way to go, but it's a lot like a computer science degree with a bit more math and just very focused electives. Up to you. Now, at the graduate level, should you go back and get a master's degree? If you want higher level positions, ones that pay more, you probably do. It also deepens your understanding of the field, which is very important. Unfortunately, a lot of these degrees focus on the technical above anything else. It won't focus on AI ethics. It may not focus on how human intelligence works, unless you take extra courses, which means more time, more effort on your part, but it can open up a lot of more opportunities. It's kind of necessary for AI research, probably all the way up to the PhD level, or for leadership, as I mentioned earlier. It also opens up a huge networking opportunity with your classmates, with your professors, and with businesses that work with the university. Something to keep in mind. Now, if you do not go to university or you already have, I would recommend earning a certification. There are some very common ones out there that are free. There are ones that cost money as well. And for these, much of any learning opportunity, you get what you put into them. You can do independent projects. We'll talk about that when we get to portfolios a lot more. You can write articles, start your own blog, create your own YouTube channel, and create videos. Reading and reviewing books. I've been doing a lot of this. Reading books, of course, you kind of need to if you want to pick up some new technologies or new perspectives. And reviewing books is a great way to get your name out there and to network with the authors and with the publishers of these books. And then a lot of the readers will see more of your work as well. Now, onto skills. Technical skills. You need to be able to program. Even if you approach things from a psychology point of view, you need to be able to build something. AI is hands-on. Math and stats are fundamental to AI. It's artificial intelligence. So anything with engineering or computers needs at least the basic math background of calculus, linear algebra, and stats. You need to know the basics of machine learning because that is the focus right now. And it will be for quite some time because that's what businesses are doing. That's what they're putting their money into. A lot of that can be solved by regression. At some universities, you can take entire courses on regression. You can find books on regression. I highly recommend to work on your skills because a lot of machine learning problems are reducible down to a regression algorithm. Human skills, communication. Can you talk to people and explain what you're doing? Can you write about your project so if someone reads it, they'll understand what's going on and why? Very, very important. You will almost certainly work with a team. Can you work with other people? That's kind of necessary. Leadership. Can you lead the team? Can you step in and lead the team if your leader is out sick or on parental leave? Can you lead the way to solving the problems? Which leads us, of course, into problem solving, which is a huge thing, because if you're not solving problems, you're probably causing them, and it's not going to look too good for you in any field. Ethics is another huge area right now. It's picking up a lot of steam in the AI area, and I highly recommend that you have a basic understanding. And now, there's no magic bullet, but the closest thing we have in the field is building a strong portfolio. So, showcase that you can actually do the hands-on work. Can you create something from beginning to end? Can you document it? Can you talk about it? It's proof that you can do the work. And I definitely recommend having a variety of projects. If you are focused in a specialty, do a bunch of those projects, but do a few things outside as well, just to show that you can, because you'll still be doing things with other specialties or working with people. Use a versioning system such as Git to allow people to go back and look and see what you changed, how you started it out, how you built it in the first place. Document everything. Keep a complete paper trail, all the changes that you make with each new version. Write tutorials, write videos of how you are doing it, but definitely have a write-up for each and every project. And you want to really network with this. If you're on LinkedIn, which I highly recommend, feel free to look me up on there. You can write about the projects that you're working on. You can post videos, which you really should be doing to have demos of where you are right now. People will chime in, give you advice, but you also have the naysayers. Ignore them. Do not do toy projects. If you go through a course or a book, they will give you the code for a toy project. You throw it together. That's not what goes into your portfolio. Your portfolio should be your work. And I highly recommend that you use real world data sets. There's so much up there. Data.gov. Google has a complete search engine just for data sets. Look that one up. There's just so many out there. Don't stick with the MNEST set of handwritten digits. Don't do the housing data stuff or the Titanic survivor stuff. Go deeper. There's so much out there. So common projects that you might want to think about. This is great if you are a generalist. So do maybe one from each of these groups. It doesn't have to be all that big. So do some machine learning. I would try out different algorithms for the same problem. Obviously, it won't be supervised for one and unsupervised for the other, as they have different goals. Do something with natural language processing. So analyze text. Text is everywhere. Vision. You have a webcam probably. It's probably built into a laptop. You can record video on your phone and upload it. You have a lot of options there. Build a robot. It doesn't have to be big. I would recommend doing this one from a book, but actually running through it and building it. There are a lot of options out there. There are a lot of websites with programs, and they do a better job than the books for giving you an outline of the cost. Do something with distributed AI. So can you do anything with networking? In our very connected world, you will need to show that you can handle this. Build a GUI. You need to show that you can interact with people. So people need to be able to control what they're saying and what they're doing. Learn the common libraries, and I don't think I have a slide for that, but I'm thinking scikit-learn, learn TensorFlow, learn Keras, learn just pandas, definitely pandas. Look them up, do the basics, find some great resources. There are a lot of free resources, but learn the basics of using them. You will not go wrong with that. Now, you need to be able to network. This is difficult for a lot of us because technical fields really bring in the introverts. Not all of us. And you're not a complete introvert or extrovert. You're in the middle somewhere, but you need to be able to put yourself out there. And LinkedIn is the number one way still to do that. It's a great way to meet new people, to get invited to talks and courses. I've been asked to speak once or twice as well, including here, thanks to LinkedIn. So definitely a thumbs up for jumping on to the platform. You should be following people that you know, following the major voices in the field, and you should leave thoughtful comments and congratulations and so on their posts. That will make them interact with you and occasionally to direct connect with you, which opens a lot more doors to a lot more people. Okay, so go to webinars, go to talks, go to conferences, ask questions, and connect with your fellow attendees. That's very important. I've done that a lot. I met a lot of great people there. Posts, you need to make your own posts as well. It should be about what you're working on, in the courses that you're taking, any thoughts you have about AI. Maybe it's a response to someone else's, so you share their post and you comment on it, but add something to the conversation as much as you can. And definitely respond to comments on your post. Now, you have to stand up. If people don't notice you, you are not going to get any offers for positions, for any opportunities, and that's kind of what you want with AI. It's still a tough field, and everything that you do should be working toward your career goal. You get your name out there, interact with people in your field so that they recognize your name. And your hands-on stuff, your portfolio, that is key to anything with AI at this point in time. Get it out there. Get your hands-on work out there in front of other people, whether it's version 0.01 beta, get it out there. Learn about related areas. I'm huge on the cognitive science side as well as computer science side. And I talk about data ethics and AI ethics a lot on LinkedIn. And above all else, always be professional. There are a lot of people, even on LinkedIn, that just mess it up for a lot of other people by being rude. They are very, very sloppy. Watch your grammar, of course. But be a decent human being. Some people still have issues with that. And those are not people that get the opportunities, that meet the people that will open up doors for them. So let's finish up. You are capable of learning AI. Anybody is. But you actually want to do it. You've got this. I don't care where you are in your career. I don't care if you are 70 years old. You can learn AI and you can have fun with it. Even if it's only a hobby at that point. Have fun with it. I highly recommend having a goal in mind. Know where you want to go. Know how to get there from where you currently are. That is your path. It's different from every other path. That's why my advice is so general. If you want to talk to me about your specific path, feel free, but this is your path and you are responsible for it. Have a foundation. The best analogy I have for your foundation is that you have a platform and you have grains of sand of what you're learning. Eventually that will fill up and anything else you learn will just fall to the sides. The bigger the platform, the more sand you have on your foundation, and the bigger things you can build, the more you can do, the deeper you can go. Know the main skills. So your technical skills, your soft skills, be able to talk to people about what you're doing and write about it. And I highly recommend finding a mentor. Find someone to talk to. You can change mentors as needed, but find one who works for you at your current stage. They can help introduce you to other people. They can help you find opportunities, and they can help keep you on the path. I wish you the very best, and I hope to hear from you soon and see you in the field. Thank you.
Hello, my name is Rob Cheek. I'm the Emerging Technologies Analyst at Hyundai Motor Securities, the investment banking arm of the Hyundai Motors Group. And today I'm going to talk about investing in robotics for massive ROE. So, a little bit about myself. As I mentioned, I am the Emerging Technologies Analyst at Hyundai Motor Securities, and under that purview, I'm also the Senior Robotics Analyst. I served as a director of innovation and business development at Eugene Robotics and was the co-creator of Go-Kart, one of the world's first SLAM-based commercial AMRs, autonomous mobile robot. I am a senior advisor at aerial robotics company Uvify. I serve as an advisor to several stealth robotics companies, and I am a consultant to several Fortune 500 companies as well. So investing in robotics for massive return on equity. So no or ROI, yes ORE, what gives? So we all know that ROI is the standard definition of return on investment and what you generally look for when making an investment decision. We submit, however, that ROE, while typically used as a metric for return on equity, which is the gain that a company makes from stock, is more apt as the term to measure business decisions made with robotics. We think about ROE as the robotics of everything. That is, where robotics technologies are developed and deployed to impact everything. If not now, then eventually. In other words, is it in the realm of robotization? Peter Diamandis said the acceleration and convergence of exponential technologies will completely reshape every industry and society over the next decade. The key for robotics companies and their investors in robotics is to leverage this concept to build robotics technologies and solutions that will serve as the pieces in this puzzle. So, question is, why are we all here? Obviously, we're here to improve the visibility into the robotics business and technology ecosystem. We may be a robotics company looking for growth, an investor looking for robotics companies with growth potential, or business looking to grow and optimize with robotics. Whatever it may be, we have a shared goal, and it's to realize outsized gains via robotics. And some of us may be students. So I like to say the highway to robot hell is populated with zombies. So much like The Walking Dead, or like zombies, they eat brains and funding in time to no good end. They use public and private funding support with a blurred vision of the market. These are useless robots. They suffer from engineering myopia. They neither excite, nor satisfy, nor solve anything. Basically, these are robots for the sake of robots. And this is no longer viable. As you all know, the promise of robotics has undelivered or underdelivered in terms of return on investment. Many may know most robotics companies, or most companies in this space, are completely useless, and as such need to be put down. However, this is coming to an end, and very quickly, and because we've seen more than our share of robots that fail to deliver to their customers or to the investors, which place their faith in these companies. So investors and the market are losing their appetite, as I mentioned, for these pie-in-the-sky robots. the pandemic has only exacerbated the situation with the shuttering of more companies. The spate of failures since 2017 has diminished investor appetite, and ultimately robots must do more than simply be interesting. They need to have a competitive edge in what they're doing, or they need to define a new category. From the silly to the nearly feasible, losses with many of these companies continue to mount. However, in contrast, gains are being made by those that provide the edge, as mentioned above. A belief that technology in and of itself is a sustainable, viable investment is misguided. Again, the promise of many robotics companies have under-delivered in terms of return on investment. And as Kevin O'Leary says, these companies really need to be taken out back and shot. The problem with many of these robotics companies are what I call the underpants gnomes business model from South Park. You approach the market with a product and then expect the market to buy in. They skip the critical middle of how they're going to achieve profit. Therein lies the key to failure. So really, when we look at the perspectives between the founder and the investor, what the founder sees is here on the upper left, and what the investor or market sees of some robotics companies is on the lower right. Design is not an afterthought. We know this thanks to the work which done at Apple, which took a company that had average or often below average technology in terms of specification to the world's largest company and brand. Done largely with power of narrative and design, built on the technology. If you took a company like DJI, which clearly wants to be the Apple of aerial robotics, you can see that it's following the form or recipe that Apple created design-wise. But what DJI is really missing is the key ingredient, and that is one of the key ingredients, and that's narrative. So neither narrative nor design is an afterthought. And despite the stream of failed social robots, tech industry veterans continue to push the narrative of why their robot is different or how they will make money and build the next awesome thing. This is irresponsible and a waste of precious resources, money, talent, and most precious of all, time. But the market is not ready for a social robot just for the sake of a social robot. There is no need for something that can be done with a roboticized system, vacuum, cleaner, car, all of which are being imbued with social capabilities. And going to the presentation, some of the major errors by robotics companies are one, Complexity must be translated to narrative that everyone understands, creating a narrative that inspires and influences. And if you don't have a story, you probably don't have a business. I like to call these "don't build me to D2s." Like the Apple Newton, these concepts were derived from social robot failures, and they will eventually pave the way to economically feasible social robotization applications and eventually viable social robots. And there are valuable lessons learned when the time is ready, and we will apply the lessons into viable products. Current thinking in social robotics and HRI focus on the robot and how it interacts with humans. And the talk even extends to issues such as robot rights, robot citizenship, and other meaningless issues, in my opinion. But my view on the current state of social robotic products certainly does not discount the value, present and future, of HRI and social robotics. It is imperative to designing robotics products and services which are in everything. For if we do not have systems which are able to interact with us humans in meaningful ways, it will certainly prove a commercial liability or risk. So, in short, the current paradigm of social robotics is broken. The way it's being thought about. And as such, the reasons why most social robotics companies will go bust. These academic enterprise social robotic failures, ventures are recipes for failures. One, the social in social robotics is overly robot-centric, not robotics-centric. Social robot product releases, despite persistent failures, drive the sector forward, and HRI must focus on interacting with roboticized systems. So, social elements within products. So, for example, a car. I think Elon Musk said Tesla is arguably the largest robotics company in the world because of their automobiles. And so they think about the social element within the cars. And really, when we think about this, there's a lot of truth to that. And the thinking about roboticized systems, that's where we really need to apply the lessons learned from social robotics research. So I'd like to talk about computerization versus robotization. They're the same, but they're different. So products went from products, mainframe, to computers, to mini, industrial computers versus PCs and embedded computers, which are in everything. The users, there were governments and large corporations versus today SMEs and consumers. Business models, purchasing, where today we're moving to service, software as a service, robots as a service, deployment, large to small to ubiquity, and convergence, computerization versus robotization. What do I mean by that? When we look at computerization, you can think about, if you would ask your grandparents about a computer, well, it's this thing in this room, or maybe it's this thing that sits on a desk, rather than their embedded computers that exist in everything around us. They're ubiquitous. In much the same way, robotization is following a similar trajectory where we are seeing robotics technologies being embedded, becoming part of everything. Again, going back to the car or a cart or you name it. There are ways that robotics are being imbued into existing products and into used to create new products, which we shall see on the market in the near future. While they do share a similar, if not the same trajectory, robotics may take slightly longer due to the complexity of cyber-physical systems versus straight digital systems and the inherent complexity of robotics relative to just computing. So really, we need to redefine what a robot is or what it means to realize, to put ourselves in a mindset to realize massive gains from robotics. So we have to break away from the traditional paradigm of robots and think in terms of robotization and develop products and businesses with robotization as the central theme. So you ask yourself, do you have a business or do you have a product? In the robotics business, there are so many companies that launch or secure funding, but in the end, they have a proof of concept. Maybe they have a product. So if you plan to invest in robotics companies or build a robot and you expect to generate massive returns, the focus should be first on business. And so you must identify and address this issue. And it's incredibly important that you make this distinction and that you do so early on. Your early decisions, your business model, your long-term trajectory, costs and workload will vary drastically depending on the path that you choose. Making the right decision will mean the difference between a windfall of profit and a complete mess. If you're building consumer robots, then it is imperative to realize that you are, in at least the near term, building a product, not a platform. Even the iPhone and many other devices, which are held up as the model for many companies, developed their own applications to support their product in the beginning. If you have built a proof of concept, then ask yourself if it is viable before you launch or you invest in it as a business. So these are examples of, these are neither product nor business nor service. I call these pictures of waste. Laundry folding robot, which cost, I don't know, $10,000 when it was released. Megabots, which were supposed to entertain people. Not ready yet, and not the time. And this abomination on the right, waste of resources. Unneeded, uncompetitive, and unsustainable investment. So Zoom, the infamous pizza robot, delivery robot pizza company that burned through $100 million, and the food was not good. It had robotic arms inside. The idea was to eventually have the the truck, the self-driving, and that the pizzas would be made en route to the customer, to the delivery point. An abysmal failure, and the Juicero, which was an app-enabled juicer. Tech hubris, nothing more than tech hubris. And so again, do you have a business or do you have a product? And if you don't know, this is what you're going to end up with. So make the right decision when building a robot or investing in robotics. So there are three sides in the business of new robotics companies and technologies, in my view. I call this conjoined triangle of robotics. It's crucial that they are in alignment for the business of robotics to succeed, or your investments to succeed. They are interdependent. While robotics companies generally come up with an idea, it is imperative that they survey and understand the market in which they serve, and they should not attempt to force their vision of what the market wants. However, there are exceptions where this has worked, but this is rare. And in the business game, you better be playing with the odds in your favor. The robotics market and customer can be understood by studying people. Trends, behaviors. It's not rocket science, but simply taking the time to look around at what people are doing, what they're asking for in order to determine how to build a better proverbial mousetrap. The investors and advisors are crucial to the process because they bring experience and domain knowledge which extends beyond the realm of robotics companies and the founders. So the operative word for achieving amazing results from robotics is ubiquity. Your robotics technology should be deployable to as many applications as possible with the shortest distance from launch to use. And we'll have a look at a few examples of success cases and explore how to make this happen, or how you can find these. For investors to realize outsized gains in robotics, they must identify and invest in companies with robotics technologies that can be applied to more than a use case. One need only look at the poster child of great robotics investments, which would be Teradyne, their acquisition of Universal Robots, Mobile Industrial Robots, and AutoGuide, all of which serve multiple verticals and which are being used to create new use cases, new products. And this has proven very profitable for the investors in Teradyne, as well as for Teradyne. And I expect this Teradyne and their investors to see outsized gains in the years ahead. On the other side of that, we can look at something like the Jibo, which was a spectacular failure and a completely useless product. And I'm remiss to even use the word product, because I guess we could call it product. So massive connections mean massive returns. The era of convergence demands a rethink of business and product design. Telephone is a perfect example of the network effect and connections. In robotics, I think companies like Berkshire Grey, which has a complete end-to-end solution for 3PL, warehousing, several other use cases. There are massive applications as only 5% of warehouses are automated, and there are far more areas where this technology will need to be deployed. And Berkshire Grey has an end-to-end solution which should prove very, very attractive for investors and Berkshire Grey's customers. I think Titan Medical is interesting. So is Vicera Surgical. Titan Medical, because they're offering what will be a lower cost version of the very successful Da Vinci surgical robot, and there is a tremendous need for these types of robots in more healthcare facilities around the world. And I think Titan Medical, with a partnership with Medtronic, will help to create more applications for these robots, generating massive returns for the investors. Kratos, who's building very interesting aerial robots to augment the U.S. Air Force, just to basically force multiplier drones, if you would. I mentioned Teradyne mobile robots earlier. I think Ouster is very interesting. Ouster LiDAR, they're unlike other robot sensor companies, the LiDAR companies that almost exclusively focus on self-driving cars. Ouster has a focus on that, but they also serve aerial robotics companies, smart cities, drones, aerial robots, mobile robots. So again, the potential return for Ouster as a company and for investors are potentially massive. And of course, while industrial sales still remain important, and of course they're on the rise, the game is changing, and again, the era of mass customization is on us, and with mass customization, we need more flexibility, and that flexibility can be provided by such robots as those offered by Universal Robot or Teradyne, which already has a tremendous user base that's growing. Your competitor may not be a robot, so if you are building a robot or investing in robotics, keep in mind that there may be a solution, or there is likely a solution that is either better or cheaper or both. So it's imperative that robotics companies and investors examine the competitive landscape to see if there's an existing or superior technology solution which can fulfill the gap that you believe that the robot is fulfilling. So of course, this is just a chart on the world spending on robotic systems. I would argue that this number is rather conservative, not touch on that too much. Global automation market, I think one of the biggest growth areas, massive returns, is going to be the warehousing market, and we see that by all the acquisitions that have been taking place. Again, Teradyne appears to be the leader in this space, but we see Zebra acquiring Fetch. We've had A few other, KUKA acquired a company called ASTI. We had a recent IPO, or rather not the IPO, the listing of Berkshire Grey, which is a pure play 3PL warehouse robotics company. Drones. Of course, the pandemic has accelerated the evolution of robotics. It also saw the death of many robotics companies, Starsky, Airware, Carex. Robots really must be of more use and do more. If you want a friend, rescue a cat or a dog. So evolution accelerated is going to really come in the form of innovation plus commercialization. I think teleexistence is very interesting. Like this robot, the Model T. They had a robot called the Model H. Again, robot for the sake of robot. It was, walk around and look at stuff. But the Model T shelf stacking robot is very interesting. With this robot, businesses in Japan, particularly convenience stores, are addressing the labor shortages and rising labor costs by using these robots to have lower cost labor from other countries work to stack shelves at their stores in Japan, and while at the same time training these robots so that they will eventually be autonomous. So it's a visible path to growth. It's practical, it solves labor shortage, provides access to lower cost labor globally, viable path to growth, using humans to train a robot for full autonomy, solves an immediate problem, raises social distancing or increases it, and lowers operation costs. So the top 5 industry with robotization potential is agricultural, food services, health, medicine, law enforcement, manufacturing, and transportation. So I like to talk about zigging. Fear of missing out. FOMO drives the zig mindset in many companies and investors. So everyone's doing this. I got to do it too. And so it's not good for the company, nor is it good for investors, because you don't generate outsized returns. In fact, you may generate an outsized or realize an outsized loss as a company or as an investor by following this path. So zigging one, there's a world of a red ocean of ultraviolet robots. Everyone wants to put a light on top of a mobile robot. It's just flooded, and most of these companies will fail. So the companies will go under, and investors and their employees will lose. And also with professional cleaning robots, this is also turning into a giant mess. Many of these companies are dependent on a couple of companies for their technology, and majority do not have any understanding or focus on multi-robot systems, and so they'll be mocked up by those with a better view of how to deploy those multi-robot systems. More zigging. Skies are polluted with drones chasing the same targets. It's just the same stuff over and over. UV robots now. Cobot arms. Everybody's making cobot arms, chasing what rethink robotics and what Universal Robot Teradyne has. And they're really arm wrestling for the same piece of the market. However, Universal has a strong lead and is widely used. So this will be interesting to watch. But again, not necessarily the most prudent thing for a company or an investor to look at. Of course, there are those that zagged. So companies like, again, Vicarious Surgical, which is a dual port surgical robot, very interesting. They received some early technology clearance by the FDA, I think the first time that's ever happened, because their technology, their solution is very, very promising. It could be very disruptive in the robotic surgical space. Dragonfly AeroVironment, U.S. North American built drones that serve different markets. Again, Kratos, Ouster, again, because they don't just simply chase the autonomous vehicle market. Uvify, which is the world leader in swarm robotics for research and also for entertainment and advertising. And of course, Universal Robot and Teradyne again. All of these companies are defining their respective markets. Thank you, and be well.